Welcome to Friendly Facts. I'm your host Raphael, and in this video we are going to find a way to think like a classical physicist. James Clerk Maxwell once wrote,
"A strict materialist believes that everything depends on the motion of matter."
I firmly believe this to be true. Everything depends solely on matter and its motion. In fact, physically speaking, there is nothing else in nature but matter in motion. This idea, which may seem reductionist, simplistic, maybe even boring to some, is nevertheless what classical physics is built on. It strives to be strictly materialistic, mechanistic, deterministic, and objective. No action at a distance, no magic, no spookiness, zero tolerance for paradoxes, no invention of pseudo-objects just to keep a beloved but failed theory afloat. So Maxwell's quote gives us the two central words of classical physics, matter and motion. It is necessary to define these terms in order to be able to use them consistently. The importance of precise definitions and careful use of scientific parlance has been stressed by great natural philosophers such as the French chemist Lavoisier, who stated,
"As ideas are preserved and communicated by means of words, it necessarily follows that we cannot improve the language of any science, without at the same time improving the science itself. Neither can we, on the other hand, improve a science without improving the language or nomenclature which belongs to it."
The American philosopher and eminent logician Irving Copey went on to say,
"Language is the principal tool with which we communicate. But when words are used carelessly or mistakenly, what was intended to advance mutual understanding may in fact hinder it. Our instrument becomes our burden."
So let's start by defining the word matter. The Cambridge Dictionary tells us, in science, matter is the physical substances that exist in the universe. The Collins Dictionary defines matter as the physical part of the universe, consisting of solids, liquids, and gases, and gives synonyms such as substance, material, body, stuff. We could extend this list by adding words like object, thing, something, entity. The problem is that we want a precise definition that we can use in physics. Defining matter as a physical substance or the physical part of the universe is not really helpful. It smacks of circularity. Dictionary.com defines matter as follows: physical or corporeal substance in general, whether solid, liquid, or gaseous, especially as distinguished from incorporeal substance, as spirit or mind, or from qualities, actions, and the like. It gets even worse now, because the word substance, which we thought was clearly a synonym for matter, has to be characterized as corporeal in order to distinguish it from incorporeal substance. We seem to be faced with a dichotomy between physical substance, that is matter, and mental substance, that is ideas, feelings, and the like. It may be wise to use different words to express this dichotomy. Let the word matter and all its synonyms, especially the word object, stand for corporeal substance, and let the word concept stand for incorporeal substance, the mind stuff that has nothing to do with physics. Dictionary.com also distinguishes between matter, qualities, and actions. The qualities of an object are its properties. These are higher order concepts that arise from underlying material structures or lower order motions, such as the charge of a proton being the motion of smaller etheric objects in the vicinity of the proton. It follows that higher order properties require a material substructure of smaller objects. So only composite matter made up of smaller objects can have higher order properties such as charge. Therefore, protons and electrons cannot be elementary particles, but must have a substructure. One might ask, what would be the ultimate non-reducible property of an object without a substructure? What is the fundamental property of matter? If we imagine an object without parts, a perfectly rigid, indivisible thing of matter, a real elementary particle, then that object can only have one property, its form, an extension in height, length and width. It doesn't even have to be spherical, but according to the principle of Occam's razor, this is certainly the hypothetically most preferable shape. This brings us to a useful and precise definition of matter as that which has form. Concepts, on the other hand, ideas such as love, happiness or ghosts, do not have form. They have no physical surface that can touch another physical surface. They are not matter, not material, not physical. Accordingly, they have no place in classical physics, which is the study of matter in motion. Let us now define motion. To do this, we go back to our elementary object with its only property of form. If we take this object to be the only matter there is, can we say that this object exists in physics? No, we cannot, because to do physics we need matter in motion. A single object cannot be said to be in motion. Motion is always a relationship between at least two objects. So now we have two elementary objects. Their distance from each other right now is not changing, hence they are not in motion. But because there is now a second object, both objects gain a higher order property, their location. We can now give the position of object 1 in relation to object 2 and vice versa. We are now able to say that both objects exist. Physical existence can thus be defined as having form and location. Location is defined as the distance of an object to all other objects. For convenience, a single appropriate object is generally chosen, such as giving the location of our moon relative not to Saturn but to Earth, although its distance to Saturn is just as physically meaningful. Motion is then simply the change of location of an object. And even if we apparently observe only one object changing its location, we can just as well say that all objects are in motion, since there is no preferred object to which a change in location can be related. Furthermore, since our elementary particles are perfectly rigid, motion can never stop. There are no losses due to higher order concepts like friction. Elementary matter can only transfer its motion to other elementary matter in perfectly rigid, lossless collisions. Matter, once in motion, will always remain in motion. From this follows that since we observe matter in motion today, we know in classical physics that matter has always been in motion. Matter in motion has always been without beginning and will always be without end. So, how to think like a classical physicist? Think of everything in nature as matter in motion. And understand that an object is that which has form. A concept is that which doesn't have form. Location is the distance of an object to all other objects. Existence is having form and location. And motion is the change of an object's location. We will dive deeper into matter, motion and concepts in the next video. For now, I thank you for watching. Please like, comment and subscribe. Till next time, auf Wiedersehen.